Hi everyone, Chapter 3, Periodic Table. In this subtopic 3.1 Classifications of Element, you will learn how to describe period, group, and block. They are block S, P, D, and F. You also need to deduce the positions of the elements based on the electronic configuration. The elements in the periodic table are arranged in order of increasing proton number, and the positions of the element can be determined by using the electronic configurations. This is how the elements in the periodic table are arranged according to the increasing proton number, and if you want to determine the positions of the element based on the electronic configuration. A vertical column of elements is called a group. So we have the group 1 until 18 in the periodic table. A horizontal row of the elements is known as a period, and there are 7 periods in the periodic table. Group, we refer to the elements in the same group have the same number of the valence electrons, thus same chemical properties. Okay. Group 1, 2. This is a group 1 and this is the group 2. Okay, group number equal to the number of the valence electrons. Means, if you know the number of the valence electron, it shows that it is also group number of the elements. Okay, for the example, okay, here I show you this is the electronic configuration for the valence electron. Okay, electronic configuration for the valence electron, we refer to the electronic configurations for the electron is located at the highest end. Okay, for the example, hydrogen. Okay, the highest end is 1 because it is located in period 1. And there are 1 valence electron occupied in orbital S. So N, it refers to the principal quantum number, highest N. From the electronic configurations of the valence electron, you see that there are only 1 electron in the orbital, shows that it is in group 1. If lithium, okay, lithium, it is located in period 2. So the highest N is 2. And the electronic configuration for the valence electron is 2s1 because it is located in group 1. So it has 1 valence electron. So electronic configuration for the lithium is 2s1. Okay, let's see for the group 2. The electronic configuration for the group 2 is ns2. N is the principal quantum number. It refers to the highest N in the elements. For the example, beryllium, it is located in period 2. So highest N is 2. So the electronic configuration for the valence electron is 2s2. There are 2 valence electrons. It shows that the beryllium is located in group 2. Okay. So for the group 1 and 2, valence electron occupy orbital S. So for the group 1, there will be 1 valence electron in orbital S. Group 2, there will be 2 valence electron in orbital S. Okay, let's see group 13 until 18. The group number, we refer to the number of the valence electron plus 10. For the example, so this is the electronic configurations for the valence electron of the group 13, okay, which is, you see that n is the principal quantum number. As I told you, it refers to the highest n, okay, highest n or outer shell, okay. Also, we also call it as the outer shell. So n, let's say boron is located at the period 2, so highest n is 2, so it is 2s2 2p1, and there are 2 electron in orbital s and 1 electron in orbital p. For the group 13 until 18, the valence electron, it will occupy orbital s and p. So the value of the n are equal. Okay, if s is 2, so orbital p also 2. Okay, remember the valence electron for the group 13, 18, it will occupy orbital s and p. So here you can see that there are, the total valence electron is 3. So to determine the group number, 3 plus 10. So it is in group 13. Okay. And I show you another example for the group 18, this one. Okay, this is a general electronic configurations for the valence electron. Okay, and S2 and P6. Group 18, it has 8 valence electron, which is 2 of the valence electron occupy orbital s and 6 of the valence electron occupy orbital p. Okay, and the value of the n are same. Okay, let's say if it is located in the period 2, so it will be 2s2 2p6, and the total valence electron is 8. And to determine the group number, 8 plus 10, so it is in group 18. Okay, let's take another example. Okay, this element, carbon, because it is located at the period 2, so the valence electron, it will occupy orbital s and p, means 2s2. Okay, this one is the group 13, so it is group 14. It shows that it has the 4 valence electrons. So 2s2 2p2. Alright, so the highest n is 2, and there are 2 valence electrons in orbital s and 2 electrons in orbital p. So all group in 13 until 18, the valence electron, it will occupy orbital s and p. And to determine the group number, the number of the valence electron at the highest n in the orbital s and p plus with the 10. So it will show the group number of the elements. Let's see for the transitions elements. In between of the group 3 until 12. Here, 3 until 12. So the group number equal to the number of the valence electron, which is it occupy the orbital s and orbital d. Orbital d, n minus 1. If here is 4, so n here 4 minus 1, so it become 3. It shows that the valence electron for the group 3 until 12, it will occupy orbital s and d. Starting from, okay, you can see that d1, the ns2 are same. Starting from the d1 until d10. Okay, for the example, I take the scandium. The scandium is located in period 4. 1, 2, 3, 4. Okay, this is a period 4. So highest n is 4, and orbital d, 4 minus 1, 3d. So here, the electronic configuration for the valence electron is 4s2 3d1. There are 2 valence electrons in orbital s and one valence electron in orbital d. So the total valence electron is 3. That's why scandium is in group 3. Okay, let's see another example. Here, okay, titanium. It also is located in period 4. So 4s2, 3d2. Okay, because here is 3d1, so here 3d2. So the total valence electron in orbital s and 3d for s and 3d is 4. So titanium is in group 4. Okay, and let's see the last example, zinc. Okay, zinc is located in period 4. Highest end is 4. Okay, and for s2, 3d, 10. And the total valence electron is 12. Okay, 10 plus 2, 12. So zinc is located in group 12. Okay, this is how you determine the positions of the elements, okay, based on the number of the valence electron. And I also show you the electronic configurations for the valence electron. Group 1 is alkaline metals except hydrogen, and group 2 alkaline earth metal. Group 3 until 12 is the transition metals, and group 17 halogens, and this one is the noble gases. Okay, let's see the S block. S block, the group number for the S block elements equal to the number of the valence electron, which is example elements in the group 1. Okay, let's say lithium. Okay, lithium with the proton number is 3. So from the proton number, you will know the number of electrons, and from the number of electrons, you can know the electronic configurations. Okay, 1s2, 2s1. So the valence electron, as I told you, it is located at the highest end or outer shell. So outer shell for the lithium is 2. Okay, and at the n equal to 2, there are only s orbital, and in the s orbital there are 1 electron. So this is the valence electrons. So the valence electron for the lithium is 1. And what is the electronic configuration for the valence electron? 2s1. Okay, if the question asks you to write the electronic configurations for the valence electron, just write the electronic configuration for the valence electron, which is it is located at the highest end or outer shell. So for the S block, okay, the valence electron is located or occupied in orbital 2s for the lithium. Okay, let's see the sodium with the proton number is 11. So this is the electronic configurations, and the highest end you can see that is 3. So there are only s orbital, and there are 1 electron occupied orbital s, shows that this is the valence electron. So there are 1 valence electron, and the valence electronic configuration is 3s1. Okay. Next, potassium with the 19 proton number. This is the electronic configurations. Highest end is 4. Okay, and it only has s orbital with the 1 electron. It shows that it only has 1 valence electron, and the electronic configuration for the valence is 4s1. Okay, for the S block, you can see that why it is a group 1 is located in the S block, because the valence electron occupy orbital s. Okay, next. Okay, still S block for the elements in the group 2. Let's say beryllium. This is the electronic configuration for the beryllium. So highest end is 2, and they are only s orbital. there are 2 electrons in s orbital, it is valence electrons. So there are 2 valence electrons, and the valence electronic configurations is 2s2. Okay, magnesium. This is the electronic configuration for the magnesium. Okay, highest n is 3, and at n equal to 3, there are only s orbital. Okay, there are 2 electrons. The 2 electrons is the valence electrons, and the electronic configuration for the valence electron is 3s2. For the calcium, this is the electronic configurations. Highest n is 4. There are 2 electrons in orbital 4s. So the valence electron is 2, and the valence electronic configuration is 4s2. Okay, let's see the p block. P block, the group number is the total number of the valence electron plus 10. For the example, we refer to the elements in the group 13. Okay, let's see boron. With the proton number is 5. So this is the electronic configuration for the boron. Highest n is 2. And at the n equal to 2, there are orbital s and orbital p. So, as I told you, for the elements in the p block, valence electron, it will occupy orbital s and p. So, at n equal to 2, there are orbital s and p. In orbital s, there are 2 electrons. Orbital p, 1 electron. And the total electrons in these 2 orbitals is 3. So, these are valence electron. There are 3 valence electron, and the electronic configurations is 2s2, 2p1. Okay, because the valence electron occupy orbital s and p. Aluminium. This is the electronic configuration for the aluminium. Highest n is 3. So at n equal to 3, there are orbital 3s and 3p. So the total valence electrons, or you can see that the electrons occupied in the orbital 3s is 2, while in 3p 1, and the total electrons in these 2 orbital 3. So valence electron is 3, and the electronic configuration for the valence electron is 3s2, 3p1. Okay, and the last one, gallium. Okay, this one is the electronic configuration for the gallium based on the Aufbau rule. So the highest n, you can see that 4. At n equal to 4, there are 4s orbital and 4p orbital. So this is the p block. Okay, because highest n, they got 2 orbital, s and p. And the electrons occupy these 2 orbital are valence electron, which is the total valence electron is 3. And the valence electronic configurations for s2, for p1. Okay, let's see another example for the p block, group 17. Fluorine, 9. This is the electronic configurations. So highest n is 2. At the n equal to 2, there are orbital s and p. So valence electron is 7, and the electronic configuration 2s2, 2p5. Chlorine. Okay, highest n is 3. There are orbital s and p. So it is in block p. There are 7 valence electron, and valence electronic configuration to 3s2, 3p5. And the last one, bromine. This is the electronic configuration for the bromine. Electron occupied in orbital 4s and 4p. Okay, at the highest end or outer shell. Okay, there are s orbital and p orbital. So there are 7 valence electron, and it occupy orbital s and p. And the electronic configuration for the valence electron is 4s2, 4p5. Okay, let's see the D block. D block, the group number, we refer to the valence electron that occupy in orbital S and D. Okay, for the example, scandium 21. This is the electronic configuration for the scandium. Okay, I told you that it will occupy orbital S and D. Okay, let's see, the highest end here is 4. So 4 minus 1. Include orbital D here. So the electrons, okay, occupy the highest end 4 and orbital D. Okay, this is the valence electron. Alright, so this is the transitions metal, and because there are 3 valence electrons, so it is in so this is the valence electronic configurations, okay, for S2 3D1 with the 3 valence electrons, and it is located in group 3. Alright, let's see another example. Vanadium. This is the electronic configuration for the vanadium. Highest end is 4. And one more tips is, you can see that the d orbital is not fully filled. It is partially filled. So if it is partially filled, it shows that it is, the element is in transition metal. Okay, so here highest end is 4, and then there are electrons occupied in orbital 3D. So electrons that occupy in 4s and 3D are valence electron. So this is the electronic configurations, and the valence electron is 5, and it is located in group 5. Zinc. This is the electronic configuration for the zinc. 4s2 3d10. Okay, here the d orbital is full. Okay, because the last group for the elements in the transitions metal is with the 12 valence electron. So this one is the one of it, which is the electron occupied in orbital 4s. Okay, full in orbital 4s and 3d. The total valence electron 2 plus 10. So the valence electron is 12, and it is in group 12. Okay, so for the elements in the D block, valence electron, it will occupy orbital S and D. Okay, let's see another example, Y, with the proton number 39. So this is the electronic configuration for the Y. Okay, you see that, okay, the highest end is 5. So 5 for the d orbital, 5 minus 1, it is 4. And the electronic configurations for the valence electron is 5s2 4d1. The electron occupied in the orbital 4s and 3d are valence electron. The total is 3. So this element is located in period 3. Okay, valence electron 3, and this is the electronic configuration for the valence electron 5s2 4d1, and it is in group 3. Okay, let's see the block. Elements in the periodic table can be classified into 4 blocks according to their valence electronic configurations. And these blocks are, they are block S, P, and these 2 blocks is the main block elements. Okay, and they are also block D and F. Okay, block S, we refer to the group 1 and 2. As I told you before, okay, the valence electron for the group 1 and 2 is occupy orbital S. So that's why the elements in the group 1 and 2 are in block S. For the transitions element, okay, the valence electron is occupy orbital S and D, right? So that's why the elements of the transition metals are in block D. And block P, okay, the valence electron occupy orbital S and P. That's why the elements are in block P. And we also have block F. Okay, below here is these two row is the block F. Okay, classify, let's see the exercise 1. Classify the following elements into appropriate group and block. Okay, let's see for the P. To determine the group and block, okay, this one you can make a table. Okay, let's say period and group and block. Okay, here group, and here is the block. Okay, let's say for the element P, highest n, okay, highest n is 3. And they are at n equal to 3, they are orbital S and P. Shows that the electrons occupied in orbital S and P is the valence electrons. So the total electrons in these two orbitals 8. Okay, because the valence, so it is the valence electron which is occupied orbital S and P. So it is block P. Okay, small letter of P, alright? Small letter of P. And it has 8 electrons, valence electrons. So for the block P, you have to plus 10 to determine the group of the elements. So 8 plus 10, it is group 18. For the Q, highest n is 4. Okay, there are orbital 4s and 4p. Still block P. Okay, there are 2 electrons in orbital 4s and 5 electrons in orbital P. The total is 7. 7 valence electron. So because it is block P, 7 valence electron plus 10. So it is group 17. Okay. R, the highest n is 4. But there are only s orbital. So it is located in block S. Okay. And the electron that occupy in orbital for S is the valence electron. Shows that, okay, for the S orbital, S group elements, you don't need to plus 10. Okay, the number of the valence electron shows that the group number of the elements. So because it has 2 valence electrons, it shows that it is in group 2. Okay, because S orbital, no need to plus 10. Only P orbital valence electron plus 10. Let's see S. Highest n is 4. There are only S orbital. So it is in S block. And there are how many electrons in S block? S orbital? 2. So it is in group 2. Okay, T. The highest n, 4s and 4p. Okay, at n equal to 4, there are s orbital and p orbital, which is 2 electron in 4s, 6 electron in 4p. And because the electron, okay, valence electron occupy orbital s and p, it is block P. And the group block P, 8 plus 10, 18. And the last one, U. Okay, you see that the highest n is 4. But at the same time you can see the orbital d is not full, it is partially full. So this is the d block elements, and the valence electron occupy orbital 4s and 3d, and this is the valence electron. Okay, there are 7 valence electron, shows that it is in group 7 block D. Okay, period. All the elements in the period have the same number of the highest principal quantum number, n, are numbered from the 1 to 7. For the example, lithium. Okay, highest n is 2. So it is located at the period 2. Highest n for the argon, 3. It is located in period 3. For the potassium, 4. It is located in period 4. And for the scandium, 4. Okay, highest n is 4. So it is located in period 4. Elements of the same period have the same number of the electron shells. Okay, let's see exercise 2. It needs you to classify, classify the following elements into its appropriate period. So for the P, highest n is 3. So it is located at the period 3. Q, highest n is 4. Right? Okay, there are 2 orbital at n equal to 4, S and P. Okay, so it is in block P, and highest n is 4. It is located at the period 4. R, highest n is 2. So it is located at the period 2. S, highest n is 4. Okay, it is located at the period 4. Okay, this one, you see that the d orbital is not full. It is partially full. So S is in D block. Okay, D block. And T, highest n is 2. Okay. So it is located at the period 2. U, highest n is 4. So it is located at the period 4. U, it is same as the S. Alright. So V, highest n is, okay, here you see that 5. Okay, 5. So it is located in the period 5. Okay. The positions of the metal, metalloids, and non-metal. Metal, we refer to the elements that are shining, solid at room temperature, and good conductor of heat and electricity. For the metalloids, okay, with the purple color, okay, it is in between of the metal and non-metal that have the properties of the both metal and non-metals. And the non-metal, we refer to the solid, liquid, and gaseous. Okay. But it is non-metals. Okay, exercise 3. The electronic configurations for the elements M and N are given as follow, and it gives you the electronic configuration for the 2 elements, and it needs you to state the group and period for the M and N. So for the M, okay, M, the group for the M is, okay, let's see M. The group for the M, okay, highest n is 3. So there are 2 orbital, S and P, and the electron occupy the S and P. The total is 3. So block P plus with 10. So it is group 13. And the period highest n 3, so period 3. For the N, highest n also 3. And there are S orbital, S and P orbital. So this is a valence electron. Okay, for the P block elements. Okay, the valence electron must plus with the 10 to get the group number. So it is 17. And highest n is 3. Okay, what is the molecular formula for the chloride compound formed by element M? Chloride form means that M combined with the chlorine. Okay, so because it is there are 3 valence electron in M, so it tendency to form positive ion. Okay, it will remove the electron from the orbital from the highest end, and it will become M3 plus. So the chloride compound formed by the element M is the MCl3. Okay, because Cl minus combined with the M3 plus shows that MCl3. Okay, and write the molecular formula for the compound formed when the M elements M and N reacts. Okay, M and N reacts. M, when it removes 3 electrons, it will become M3 plus. And N, to achieve the stability of the noble gas configurations, it has to accept 1 more electron. Okay, you see that it needs 1 more electron to achieve the noble gas electronic configurations. Okay, means that N, it will accept 1 electron, it will become N minus. So this one M3 plus, this one N minus. So the molecular formula for the compound between M and N is MN3. Okay, right. The figure shows the locations of the element Q, R, T, S, and Y in the periodic table. So choose an element that is a halogen. So we know that halogen, we refer to the elements in group 17 from this periodic table. Of course, Y, okay, is the halogen. And which element is the monoatomic? Okay, monoatomic, we refer to the it exists as a atom, monoatom. So of course it is group 18. Okay, it exists as a monoatomic R. And write the SPDF notation for the electron arrangement for an atom of the element Y. Okay, Y, we know that it is located at period 3, right? 1, 2, 3. So, and it is in group 17. It shows that Y has 7 valence electron and the highest end is 3. So, the electronic configurations, maybe you can start with the electronic configuration for the valence electron. Highest end is 3 S. 17 means that it has the 7 valence electron, which is 2 in orbital 3s and another 5 electron in orbital 3p. So this is the electronic configuration for the valence electron based on the information from the periodic table. And because it needs the electron configurations, you have to give the full electronic configurations. So you complete the previous electronic configuration for the Y. Before 3s is the 2p6, 2s2, and 1s2. So this is the electronic configurations for the Y. Suggest one possible set quantum numbers for the valence electron of atom of element T. Okay, element T here. Okay, it is located in period 3, group 1. Okay, it shows that it has 1 valence electrons. So, it needs one possible set quantum numbers for the valence electron. So, for the only 1 valence electron, okay, because it is in group 1. It is, okay, as I told you, set quantum numbers. It is the combination N, L, M, S. Okay, let's say you can write like this, this one, and okay, because it is located in period 3, so highest N is 3, so N equal to 3, comma, L equal to Okay, because it is group 1, the valence electron is occupied orbital S. So S indicate it is, the L is 0. And then M, orientations. When L 0, M also 0. And S, either positive half or negative half, one of it. So I put here is the positive half and put the bracket. So this is the set of the quantum numbers. Okay, one set only, because for the one valence electron. Okay, the last question is the draw orbital diagram for the atom of element Q. Element Q here. Okay, draw the orbital diagram. Let's see. For the atom of the element Q. Okay, same as the C. Okay, question C. But this one, it needs you to give the electronic configurations in the form of the orbital diagram. So let's see. Okay, Q. Okay, I write down here. Okay, Q, we know that it is located in period 2 and group 14. It shows that it has 4 valence electrons. At the highest end is 2. Okay, because it is located in block P. So the 4 valence electron occupy orbital S and P. Okay, so shows that, okay, S and P. So let's say this one 2S and 2P. Make sure got space between 2S and 2P larger compared to the space in between of the P orbital. Okay, so these two P orbital. So because there are 4 electrons, okay, singly first, Hans rule. And then this is the valence electronic configurations in orbital diagram for the Q. Then you complete the previous valence electrons, previous electronic configurations, which is occupied in orbital 1s. Okay, so this is the electronic configurations in orbital diagram for the Q. Okay, that's all. Thank you.